So let's answer number 3. In 3, we're going to answer what is the purpose of mutual inductance. The mutual inductance is simply, you have obviously mutual inductance here. You have a primary winding here, right? And then you have a secondary winding here, right? So what happens in a mutual inductance is that your current is being transferred. Let me erase this real quick to make it easier for you. So obviously your primary is here, your secondary is here, all right? And obviously this is I, and this is obviously going to be some current here. So what happens now is you have a magnetic field that's kind of going around this way, right? So what happens is that your energy is transferring, right? You have an energy transfer, I would say kind of a current or electricity transfer without loss. Why is there no loss? Because the current comes in, converts to a magnetic field, and then it comes back to a current on this side. We call this I1, I2, or we have a V1, and then we have a V2, and then you have your windings, right? So this is really kind of like the Faraday's law, where you have your current, and then you have your magnetic field, right? So current transitions to magnetic field, it transfers, it goes back to current, and it's encapsulated, so there is no loss. That is how you answer B, right? You transfer without any loss. B, right? So, or I wouldn't say without any loss. We would have to say probably minimal loss. I think that's probably a better word, minimal loss. Okay. B, you have a primary, secondary. So we have a primary, and we will draw the primary here, and we will draw. Sorry, let me finish this. Okay, so now we have our transformer here, and then we have our transformer here, right? These are our windings of the transformer. And so the question is, if our primary is 500 and our secondary is 100. So we have obviously a V1 on the primary side, and then the V2 is on the secondary side, and this is N1, N1, and then N2, just like that. So we have an N1, N2. So the equation is the following. V1 over N1 is equal to V2 over N2. Okay, I'm asking for the what is the coil ratio, right? So the coil ratio on this is, V1 over V2 is N1 over N2. And then what we're going to do is we're going to say it's 500 volts to 100 volts. And so that N1 over N2, okay, is what? This is a coil ratio, right? We want the primary to secondary, we need a drop. And so this is a coil ratio of 5. Okay. Now, what we want is on C, so let's go to part C. C is, if primary is 10 amps and the coil ratio is 2, what is I secondary? Well, you have I1 N1 is equal to I2 N2. So I'm asking for the secondary, which is I2 here. So I2 is equal to what? I1 N1 divided by N2, just like that. Okay. So that gives me what? That's I1 N1 over N2. Okay, no problem here. So we say that it's I2 is equal to, which is primary, I2 is secondary. So this is 10 amps is primary, coil ratio is 2. So this is 10 times the coil ratio, which is 2, right? And so we have 20 amps. So we can see that with a coil ratio, our voltage can drop here, right? A voltage drops from 500 to 5 volts, but we can also increase the current with a coil ratio of 2. I'm sorry, this is not 5. I'm sorry. We can see that with our coil ratio 5, we can see a drop voltage from 500 to 100. But then when we have a coil ratio of 2, we can see a current rise, right? So it can work either way, right? So this is the problem for number 3.